Hi guys, today we're going to be doing A-Level for the Maths, October-November 2023, paper 1-2. So we'll start now. First question. By using the standard results from the list, we need to find the sum of 3r squared plus 3r plus 1 in terms of n. So let's write it down. We can actually separate the coefficient of r squared and r out. We can actually separate it into this form since it's just the summation. The answer will be the same. So 3 times 1 over 6 n plus 1 to n plus 1. This can all be found in the formula booklet, yeah? And lastly, the summation of 1 is just n. So both of this can actually be found in the formula booklet in this area here. So we can expand the brackets now. 2n squared plus 3n plus 1 plus 3 over 2 n squared plus 3 over 2n plus n. So this will be n cubed plus 3 over 2n squared plus 1 over 2n plus 3 over 2n squared plus 5 over 2n. And the final answer will be n cubed plus 3n squared plus 3n. For part B, first we need to show this equation. So we need to show that this minus this is equals to this whole thing. And then we need to use the method of differences to find the summation of this. So first, we would prove this equation first. R plus 1 cubed. So we make it into one fraction. R plus 1 cubed minus R cubed. And then R cubed times R plus 1 cubed. So we will get R cubed plus 3r squared plus 3r plus 1. Basically just expand the bracket using binomial expansion. And finally we have minus r cubed over r cubed times r plus 1 cubed. So we will get 3r squared plus 3r plus 1 over r cubed times r plus 1 cubed, which is exactly this one. Next, we're going to use the method of differences to find the summation of that. So the sum of this fraction is basically the sum of 1 over r cubed minus 1 over r plus 1 cubed. Because we just proved that this is equals to this. Alright. So for method of differences, we just need to start from r equals to 1 followed by r equals to 2 and r equals to 3, and after that we can jump to r equals to n minus 2, r equals to n minus 1, and r equals to n. So when r equals to 1, we just look at this expression. When r equals to 1, we have 1 over 1 cube minus 1 over 2 cube. We don't even need to find what 2 cube is for now. So when r equals to 2, we get 1 over 2 cube minus 1 over 3 cube. When r equals to 3, we get 1 over 3 cube minus 1 over 4 cube. When r is n minus 2, we get 1 over n minus 2 cube minus 1 over n minus 1 cube. And we do the same thing for r equals to n minus 1 and r equals to n. So we get all this, and since it's a summation, we're going to sum all of this up. But we can see that this row is plus and this row is actually minus. So we can just cancel them off. So 1 over 2 cube can be cancelled off with 1 over 2 cube. So this plus this is equal to 0. And this can be cancelled off with this. This can be cancelled off with something here, so on and so forth. This and this, this and this. So we are basically left with these two. So we can say that the summation of 3r squared plus 3r plus 1 over r cubed times r plus 1 cubed is basically 1 minus 1 over n plus 1 cubed. And this will be the final answer. So for part C, we need to deduce the value of the summation when n is replaced by infinity. So basically, we just take this and we change the n to infinity. So we get 1 minus 1 over infinity plus 1 cubed, which is 1 minus 1 over infinity. And this would be equals to 0. 1 over infinity is 0. Anything over infinity is 0. So we get 1. So 1 will be the sum to infinity of the whole expression. Second question is about mathematical induction. And for mathematical induction, we have 3 steps. First, n equals to 1. Second, n equals to k. And third, n equals to k plus 1. So let's start with n equals to 1. For n equals to 1, we need to prove that the left-hand side is equals to the right-hand side of the equation. So for left-hand side, the derivative of x squared times e to the power of x is x squared ex plus ex 2x. So it's equals to x squared plus 2x times e to the power of x. For right hand side, we get x squared plus 2x plus 0 times e to the power of x. So we can see that the left hand side is equal to the right hand side. So just write it out. Left hand side equals to right hand side. So this statement is true for n equals to 1. And for the second part, for n equals to k, we assume that this, so we just rewrite the whole statement out, but we sub k into n instead. So we assume this whole statement is true. So for the third part, which is for n equals to k plus 1, we verify that the statement is true. But for now, we have to sub k plus 1 into n instead. So we have this whole thing. We verify that this whole thing is true. So just like how we did in n equals to 1, we can start from the left hand side. So how do we do this? So this is basically the derivative of dk over dx of k and so on. This is basically this, right? We can write this as this. And from part 2, we assume that this is equals to this. So we can just sub this whole thing inside here. So what we do is, since we assume that it is true, we sub it in. And now we just need to differentiate this one. And it's pretty easy. We just use the product rule. And we just simplify the whole expression. So we get x squared plus 2k plus 2x plus k squared minus k plus 2k times e to the power of x. And we can simplify it to x squared plus 2 times k plus 1 x plus k plus 1 ex. And this is just this. So we found the exact form that we want. So we can also write that it's equals to the right hand side. So the statement is true for n equals to k plus 1. And now we have to write the conclusion, which is by mathematical induction, it is true that this statement, so we just copy it down, it is true that this is equals to this for all positive integers n. For this phrase, we can also just copy it from here. And we are done with this question. Question 3 is about matrix, and we are given that M is a combination of two transformations. And we need to state the type of each transformation. So this would be the first transformation, and this would be the second one. The order goes from this to the next one to the next one, instead of from the left one to the right one. So if we see that both of these numbers are 1, and there's a number here that is different from the number here is different from the top right corner, we can know that the first transformation is a shear. So we can write shear followed by, so the second one, we can see that the scale factor is at the top left corner. So if it's in the top left corner, it's a stretch parallel to the x-axis. If this is 1 and this is k instead, then it will be parallel to the y-axis. For part B, you need to find the area of the parallelogram and the matrix that transforms OPQR to the unit square. So what it says here means that there's a square that is transformed by M into OPQR. So this is by M, and the area of the unit square is just 1. What it means by unit square is that the area is 1. So now we need to find the area of the parallelogram, and the area of image is just the determinant of whatever that transforms it times the area of object. And in this case, the area of object is 1. So the area of OPQR is basically just the determinant of M. So let's just find what M is. M is K001 times 1, 0, 1, 1. So m is k 0, 1, 1. And the determinant of m is k. So the area of OPQR is k times 1, which is also k. So we are done with the first part. And now we need to find the matrix that transforms OPQR into the unit square. So the square is transformed by m into OPQR. So now we need to find the matrix that transforms OPQR back to the square. And it's basically just the inverse of m. So how do we find the inverse? It's 1 over the determinant, which is k, times. So what we do is we move these two, we exchange these two. So instead of k, we have 1 here, and k is here. And for these two numbers, we just change the sign of it. So this one is positive 1, so we change it to negative 1. And 0 is just 0. This is how we find the determinant, the inverse of a 2 times 2 matrix. So we get 1 over k, 0, negative 1 over k, 1. This will be the matrix that transforms OPQR onto the unit square. For part C, we need to show that the line through the origin with gradient 1 over k minus 1 is invariant under the transformation by m. So what is an invariant line? So let's say this is an invariant line. We have our object here. Let's call it O. So if O is transformed by m, its image will be along the line, along this invariant line. So it can be here, here, or just anywhere in this line. So let's just assume that this is the image. So it's saying that this line has a gradient 1 over k minus 1, and it passes through the origin. So this line is y equals to 1 over k minus 1 x. So how do we prove that this line is an invariant line? Okay, for the object, we call this O, and it has coordinates of x and 1 over k minus 1x. So now we prove that the image has the same form similar to this. It has the form similar to this. So we take the matrix M times the object, and we can see that this is kx, and this is x plus x over k minus 1. And we can simplify this into kx minus x plus x over k minus 1. And this is kx and kx over k minus 1. And we can factorize the k out to get x and x over k minus 1. And now, see that this coordinate is basically this coordinate. But instead, the image is just k times whatever is here. So we prove that the line with the gradient 1 over k minus 1 is invariant under the transformation M. For question 4, this equation has roots alpha, beta, and gamma. And we need to find another equation with roots of 3 alpha plus 1, 3 beta plus 1, and 3 gamma plus 1. So, first, we need to let y equals to 3x plus 1. Why is that so? The first equation has the roots of x equals to alpha, beta, gamma. The second equation, the roots are y equals to 3 alpha plus 1, 3 beta plus 1, and 3 gamma plus 1. So you can see that we just sub y equals to 3x plus 1 because it's in the same form. We just sub this and we make x a subject. So x is now y minus 1 over 3. And we sub this into the original equation to get 27 y minus 1 over 3 cubed plus 18 y minus 1 over 3 square plus 6 y minus 1 over 3 minus 1 equals to 0. And now we expand the brackets. So 3 cubed is basically 27, so this can be cancelled off. So it's just y cubed minus 3y squared plus 3y minus 1. And 3 squared is 9, so you get 2 times y squared minus 2y plus 1. And 2y minus 1 minus 1 equals 0. And now you simplify it, you will get y cubed minus y squared plus y minus 2 equals to 0. And this is what is given here. For this type of questions, first we need to know that if we have an equation in this form, the sum of roots is negative b over a. Sum of two roots is c over a, and the product of roots is negative d over a. So what is sum of root? It's basically alpha plus beta plus gamma in this case, since there's only 3 roots. And the sum of two roots is basically alpha beta plus alpha gamma plus beta gamma. And this is just alpha times beta times gamma. So, in this question, it states that Sn means the sum of this. So we need to find S2 and S3. And firstly, we will need to find S1. So S1 is the sum of roots of this equation. Let me copy it down so we don't have to refer it later. So this is the equation, and the sum of 3 alpha plus 1 is basically 1, because the roots is already in this form. Okay, so S1 is 1, S2 is basically the sum of roots square. So sum of root square is the square of sum of root minus 2 times the sum of alpha beta. So what's the difference between this and this? This is basically 3 alpha plus 1 squared plus 3 beta plus 1 squared plus 3 gamma plus 1 squared. And this is 3 alpha plus 1 plus 3 beta plus 1 plus 3 gamma plus 1 squared, the whole thing. So this will be 1 squared minus 2 times 1 plus this is just 1 over 1. So we get negative 1 for S2. And S3, we can rewrite this equation into this form. S3 minus S2 plus S1 minus 2S0. If you want to know why we can write it in this form, you can refer to the video of October-November 2023 paper 1-1. Okay, so we need to find S3. So we just sub the values of S2 and S1. So S2 is negative 1 plus S1 is 1 minus 2. S0 is basically alpha to the power of 0 plus beta to the power of 0 plus gamma to the power of 0. So S3 is S3 plus 1 minus 2 times 3 equals to 0. Because anything to the power of 0 is just 1. So 1 plus 1 plus 1 is 3. And S3 in this case would be equal to 4. For part C, we will need to find the values of S negative 1 and S negative 2. So for equation in this form, we can actually step up like this. So let's step up by 1. So we can actually write it as S4 minus S3 plus S1 minus 2S2. Sorry, 2S1. This is 2, sorry, equals to 0. We can actually write in this form. Or you want to step up by 2. If you want to step this up by 2, it will be S6 minus S5 plus S4 minus 2S3. You can actually write it like this. Similarly, you can step down. So, if you step down by 1, you get S2 minus S1 plus S0 minus S negative 1 equals to 0. And if you step it down even more, you get S1 minus S0 plus S negative 1 minus S negative 2. And we need to find this and this. So we'll do it step by step. First step, we will step it down from this to this. So let's just move this aside first. And we can get s negative 1 in this case. So s2 is just negative 1 minus s1 is 1 plus s0 is 3 minus 2s negative 1 equals 0. So 2s negative 1 is 1 and s negative 1 is 1 over 2. So now we will use this to find s negative 2. So s1 is 1 minus s0 is 3 plus whatever that we got here, which is 1 over 2 minus 2s negative 2. So 2s negative 2 is negative 3 over 2, and s negative 2 is negative 3 over 4. For question 5, we have a plane that has the equation in this form, and now we need to find it in the form of ax plus by plus cz equals to d. So in the original form, we have a point. This is a point on the plane. Let's call it A. This is one of the directional vector in the point. Let's call it D1. And this would be the second directional vector on the plane. And in order to find this form, we need a normal vector. And normal vector is just the first directional vector cross product with the second directional vector. This would be 2, negative 8, and 6. And we can factorize the 2 out, so we get 1, negative 4, and 3. And the formula for the equation is r dot n equals to a dot n. The dot here represents the dot product. So r, you can write it as x, y, z, dot product with the normal equals to a, which is a point on the plane, which is this one. So we can just write it here. 1, negative 1, negative 2, dot with the normal vector again. So we get x minus 4y plus 3z equals to 1 plus 4 minus 6. And the final answer would be x minus 4y plus 3z equals to negative 1. For part B, we have a line L which does not lie in that Cartesian plane. And now we need to prove that L is parallel to the plane. So let's say this is the plane, and we have line L, which is parallel to this. It means that, let's say this is the normal vector of the plane. It means that the normal vector is also perpendicular to the line L. So now we just have to prove that line L and the normal vector are perpendicular to each other. So this will be the directional vector of line L, which is 1, 1, 1, dot product with the normal vector, which is 1, negative 4, 3. It's 1 minus 4 plus 3, which is 0. So let's just explain a little bit. Line L is perpendicular to the normal vector of the plane. Since it does not lie in the plane, it is parallel to it. So now we need to find the distance between L and the plane. Since they are both parallel to each other, the distance between them is always the same no matter which point we choose. So we can use the formula of d equals to the modulus of a minus b dot product with the unit vector of n. So what is a minus b? Both of these are just points. It can be either one is the outside point, which is the point that's not in the plane, and this can be the point that's inside the plane. You can switch it because by the end of the day, we are still getting the modulus of it. So the answer will be the same. And this is the symbol for unit vector. So now we need to find a minus b. We know that this is a point on the line that is stated here. This is the point on the line. And for the point in the plane, it's this one. So we already have 2 points. And the answer is -4, 1, and 3. So now we just sub it back to the formula. So we get -4, 1, 3 dot product with n, and we want the unit vector, so you need to divide by this. And modulus it. So this thing is the unit vector of n, and this thing is a minus b. Okay, so we would get -4 minus 4 plus 9 over 36. And the final answer would be 1 over 36. For part D, we have another plane with this equation. And now we need to find the line of intersection of plane 1 and plane 2. So we have the equation of the first plane, which is x minus 4y plus 3z equals to -1. And the second plane is 3x plus 3y plus 2z equals to 1. This is the first equation. This is the second equation. And this is basically just simultaneous equation. I'm gonna times 3 to this whole equation, so I get 3x minus 12y plus 9z equals to -3. This will be the third equation, and I will take the second equation minus the third equation to get 15y minus 7z equals to 4. And I'm gonna let y equals to 0. You can let z equals to 0 as well. it's gonna be the same. The mark scheme accepts all three answers. If you let x equals 0 or y equals 0 or z equals 0, the mark scheme accepts them. So yes, I'm gonna let y equals 0 since the coefficient is larger, so I guess it's easier. In this case, negative 7z would be equals to 4, and z would be equals to negative 4 over 7. And I'm gonna find x. So x minus 4y, which is 0, since I already let it to be 0, plus 3z is 4, sorry, negative 4 over 7 equals to negative 1. And x, in this case, would be 5 over 7. So we have found the one of the points on the line of intersection. And now we need to find the directional vector for the line. So the directional vector, we can just take the cross product of the two normal vectors. So the first normal vector is 1, negative 4, and 3. This is the normal vector of the first plane. Cross product with the normal vector of the second plane, which is 3, 3, 2. So the answer would be negative 17, 7, and 15. So I can write my line of intersection in this form, which is r equals to the point of intersection is 5 over 7, and y is 0, z is negative 4 over 7, plus t directional vector is negative 17, 7, and 15. You can, for this, you can put t, you can put lambda, you can put mu, or anything you want. So this can be different depending on which variable you let it as 0. If you let x as 0, then you will get a different answer for this point. But the directional vector should always be the same. For question 6, we need to sketch the polar equation. We need to sketch the curve. So let's just roughly see what values we can get when theta is of different values. So the question only wants for 0 to pi over 2. So we can start from 0, get pi over 6, and pi over 4, pi over 3, and pi over 2. These are those that are nicer looking angles. Yes. So theta is 0, r is 0.8. You don't have to write the exact form since we just need a rough idea of how it's gonna look like. So you can just put it in decimal places. So 0.8, and this would be 0.4, this would be 0.2, 0.1, and 0. So now we can sketch it out. This is 0, this is pi over 2, pi over 4 will be in the middle, around here. Pi over 6 would be around here. Yeah. And pi over 3 would be around here. So when theta is 0, r is around 0.8. So let's put it here. Pi over 6, r would be 0.4, which is half of 0.8. I'm just going to put it here, let's say 0.4. And for theta equals to pi over 4, it's 0.2, which is half of 0.4, so I just put it here, 0.2. And for pi over 3, it's 0.1, which is even shorter, 0.1. And for pi over 2, it's 0, it's just here. So the shape is around this. I'll try to draw it nicer. Oops. Okay, this is the rough sketch of the curve C. And now we need to state in exact form the greatest distance of a point on C from the pole. So pole is this point here. So we can see that the furthest distance, the point with the furthest distance is this point. So it's basically when theta is equals to 0. So now we need to find r when theta equals 0. So we just sub 0, and this is negative pi 2. So it will be 1 minus e to the power of negative pi over 2. So this would be the greatest distance from the pole. Now we need to find the exact value of the area of the region bounded by C and the initial line. It's basically this area. Yes, it's basically this area, this whole area here. So basically, just sub it into the formula. So the area is 1 over 2, and the integration from 0 to pi over 2. Squared d theta. The formula is basically 1 over 2 integration of the first angle to the second angle, depending on the region that we want to find, and r squared d theta. This is basically the formula. So we just sub it back in. Okay. Let's just expand the bracket first. And we will get negative half e to the power of 2 theta, negative 2 theta plus 2e to the power of negative theta minus pi over 2 plus theta times e to the power of negative pi. Sorry, that was my cursor of my laptop. Okay, so it will be from 0 to pi over 2. So now we sub the values in. So it's half times negative 1 over 2 e negative pi plus 2e to the power of negative pi plus pi over 2 to the power of times e to the power of negative pi plus half minus 2e to the power of negative pi over 2. This will be equals to 1 over 2 times 3 over 2e to the power of negative pi plus pi over 2 times e to the power of negative pi minus 2e to the power of negative pi over 2 plus half. And now we just simplify whatever that we got just now. For part C, we need to prove this equation at the point on C furthest from the initial line. So initial line is basically this line over here. And here's a tip. If they want it from, okay, so if it's the furthest from the horizontal axis, you use dy d theta equals to 0. If they want it from the vertical axis, you use dx d theta equals 0. If they want it from the pole, you use dr over d theta equals to 0. So for now, they want it from the initial line, which is the horizontal axis, so we would use this one. But we can see that the equation that they give initially is in r, it's not in y. So we need to change it. So we know that y is equals to r sine theta, and we can just sub the equation into r. And now we get it in terms of y and theta. So for now, we need to find what dy over d theta is. So let's just do our differentiation. So this would be our dy over d theta, and we need to equate it to 0. So this whole thing equals to 0. And we can move it in this way. Equals to e to the power of negative theta sine theta. And now, since the equation has tangent, we can find tangent when we move this to this, right? So e to the power of negative theta minus e to the power of pi over 2 over e to the power of negative theta equals to sine theta over cos theta. And this would be 1. This would be negative e theta minus pi over 2. and this would be tangent theta. And let's just put it in the form that they want. And we're done. But we need to verify that the root is between 0.56 and 0.57. So we just sub theta equal to 0.56 and 0.57. When theta is 0.56, we get 1 minus e to the power of 0.56 minus pi over 2 minus tangent 0.56 equals to 0.00912 to 3SF. Let's just move it here so we have more space. So when theta equals to 0.57, we get 1 minus e to the power of 0.57 minus pi over 2 minus tangent 0.57. And we would get negative 0.00856 rounded to 3 SF. So we can clearly see that there's a change in sign. This is positive, this is negative. So since there is a change of sign, the root of the equation lies between 0.56 and 0.57, and we're done. For question 7, we have equation y equals to fx, where fx is x squared over x plus 1, and we need to find the asymptotes of c. Okay, this is an improper fraction. And to find the asymptotes of an improper fraction, we need to change it into another form. So, okay, what is an improper fraction in terms of x? So when the numerator has a larger degree of x than the denominator, or equal to the denominator, it's considered an improper fraction. So let's say I have x over x plus 1. It is also considered an improper fraction. Right? So we can divide it. So fx can be written as x minus 1 plus 1 over x plus 1. And one of the asymptotes would be y equals to x minus 1. For the other asymptote, we need to equate the denominator to 0. So x plus 1 equals to 0, x equals to negative 1. So the asymptotes are y equals to x minus 1 and x equals to negative 1. Now we need to find the stationary points on C. So we just need to differentiate this. expression. So we get x plus 1 times 2x minus x squared over x plus 1 squared. And it would be 2x squared plus 2x minus x squared over x plus 1 squared. And we get x plus 2 over x plus 1 squared. And to find the coordinates, we need to equate it to 0. So x times x plus 2 over x plus 1 squared equals to 0. And we get x times x plus 2 equals to 0. X is 0 and x is negative 2. And now we sub it back into the equation. We sub it back into the expression to find for y. Negative 2 squared, negative 2 plus 1. So we get negative 4. So the coordinates is basically 0, 0 and negative 2, negative 4. Done. Now we need to sketch C. So let's draw the axis out first. This is y and this is x. And we need to draw the asymptotes, which is x equals to negative 1 and y equals to x minus 1, which is here. Around here. Y equals to x minus 1. So from part B, we can tell that there are two stationary points on C. And for this kind of graph, if there is a vertical and a diagonal asymptote, and there are stationary points, that means the shape of the graph should be around like this, around this kind of shape. So if there are no stationary points, they are normally shaped like this. Alright? So now we know that the stationary points are 0, 0 and negative 2, negative 4, which is here, negative 2, negative 4. So it's around here, I would say. Not very accurate, but sure. So yeah, we can just sketch it out. This is an easy one. We need to make sure that the graphs don't touch the asymptotes, and this should be the minimum point and this should be the maximum point. So it shouldn't go over these points. And we are done for graph sketching. For part D, we need to find the coordinates of stationary points on the curve with equation 1 over fx. So when we have 1 over fx, the coordinates of the stationary points are basically like this. For the x coordinate, it stays the same. And for the y coordinate, we need to flip the fraction. What do I mean by this? Okay, first, remember that we have 0, 0 and -2, -4. So 0, 0 would be the same since you can't flip this fraction, right? And for part E, we need to sketch the curve with equation y equals to 1 over fx. So to sketch this graph, there are a few things to take note of. First, the asymptotes of the original graphs. The vertical asymptote is now the x-intercept of the new graph. And the horizontal asymptote stays the same. So it's also the horizontal asymptote of 1 over fx graph. Second, we have turning point. So, like what we said just now, the x coordinate stays the same, and the y coordinate, we need to flip the fraction. Thirdly, the intercepts. So, the x-intercept of the fx graph is now the vertical asymptote of the 1 over fx graph. And for the y-intercepts, we just flip the fraction, and it would be the y-intercept of the new graph. Number 4, the limits. So when y is approaching positive infinity, in the new graph it will be approaching the positive 0. When y is approaching negative infinity in the fx graph, it will be approaching negative 0 when it's 1 over fx. And if y is approaching positive 0 in the y equals fx graph, it would be approaching positive infinity in the new graph. Similarly, when y is approaching negative 0, it will be approaching negative infinity in the new graph. And for this part, I know it's a bit confusing. I will explain it later. And lastly, fx and 1 over fx meet at y equals to 1 and y equals to negative 1. That means at y equals to 1 and y equals to negative 1, both of the graphs should meet. That means they should have the same x and y coordinate at y equals to 1 and y equals to negative 1. So I will make this smaller so we can refer it, but it doesn't block out the space. And I'll copy this graph so that we can refer it later. Okay, so let's draw the new graph. Firstly, asymptotes. Okay, the vertical asymptote is now the x-intercept. So this asymptote is now the x-intercept of the new graph. That means x equals to negative 1 would be an x-intercept. And for horizontal horizontal asymptote, it stays the same. But we do not have any horizontal asymptote here. We only have an oblique asymptote. But we don't really have to care about the oblique one. So we can go to the next one. For turning point, the x-intercept is the same. Sorry, the x-coordinate is the same. And the y-coordinate, we just flip the fraction. And from the previous part, we know that this is the turning point of the new graph. So we have -2, -1/4. So -2, -1/4. This would be the turning point. And for the intercepts, the x-intercept in the previous graph will now be the vertical asymptote. So this would now be the vertical asymptote. This will be the vertical asymptote for y equals to 1/fx graph. And for the y-intercept, we need to flip the fraction. But we do not have any y-intercept except for this. But since this is an asymptote now, we do not have any y-intercept. Okay, for the fourth point, this one. When if y is initially approaching positive infinity, it would now be approaching positive 0. So for this part and this part, they were originally approaching infinity, right? Approaching positive infinity. So now it would be going towards positive 0. So this part and this part would be around, like, it would be around this shape. And if y is initially approaching negative infinity, then it would be now approaching the negative 0. So for these two parts, it would now be approaching 0, negative 0, around this shape. Okay? And for the one that is initially approaching positive 0 is now approaching positive infinity. So this part would now be approaching infinity, approaching positive infinity, which is around this shape. And if it's initially approaching negative 0, it would now be approaching negative infinity. But we do not have any part that's approaching negative 0 here, right? So we don't have to care about the last part. Okay, so now we can roughly sketch the graph. We know that just now we state that the shape here is around like this and like this, since this is approaching the positive infinity and this is approaching the positive 0. So we can do this. Alright, and we also state that at this part it's approaching positive infinity, and for this part it's approaching positive 0 since it was like this. So now we know that this is an x-intercept. So we can just draw it like this so that it touches the x-intercept. And we also say that the shape is around like this, right? And do note that there's a turning point here, so we can just connect them. Yes, this would be the new graph. And now we have to find the set of values for which 1 over fx is larger than fx. Okay, now it's time to look at the fifth point. Fx and 1 over fx meet at y equals to 1 and y equals to negative 1. That means if I have a line here and a line here, this is y equals to 1 and y equals to negative 1. These two coordinates should be the same as these two coordinates. This is y equals to 1, yeah? And I have another line which is y equals to negative 1. So these two coordinates are the same as these two, since they should meet at y equals to 1. So which part of the graph satisfy this inequality? So we know that 1 over fx should be larger than fx. So we can see that this part is definitely satisfy the inequality. And another part would be right here, since we can see that this is already lower than y equals to negative 4. So obviously this would be larger than this. And the last part would be this part. Oops. This part. Where you can see that 1 over fx is above y equals to 1 and fx is below y equals to 1. And now we need to find the set of values that satisfy the inequality. So we need to find the x coordinates of these points. Okay, how do we do it? We just equate this to 1. So we can do it here. X squared over x plus 1 equals to 1. So x squared is equals to x plus 1. X squared minus x minus 1 equals to 0. X is equals to 1 plus minus 1 squared minus 4. 1 times negative 1 squared the whole thing over 2. And it's basically 1 plus minus 5 over 2. So this is 1 plus sub 5 over 2, and this is 1 minus sub 5 over 2. And we would need to just write the set of values. So for this area is basically x less than negative 1. So let's just write it down. X less than negative 1. And for this area, we can say that it's in between these two x values, but x is not equals to 0. Okay? So 1 minus z5 over 2 less than x less than 1 plus z5 over 2, and the x is not equals to 0. And we're done.